everything that we're looking at for using a drone to do, we already have another way to do it. So if we're looking at pavement forensics, we have calibrated bars, we have profilers, we have LiDAR. And what we want to be able to do is figure out if a drone, if using a UAV, can in some way benefit us. So does it improve safety? Does it give us better data, more accurate data, more complete data? Can we get the data more safely? I was interested in the surveying part of it, so the mapping part, the geomatics part, versus strictly the inspection part. And so we see, because of the unique perspective that a drone gives us, elevated above what we can see on the ground, it allows us to see around obstacles, maybe gather information that we're not able to gather in any other way.
They will be used for collecting data on different types of infrastructure. We're talking about pavements, we're talking about bridges, and we're also looking at railway corridors, and we also did volumetrics on stockpiles.
We have used the unmanned aerial vehicles coupled with close-range photogrammetry. The photogrammetry means the science of measuring distances from two or more images. That is, when you take images of an object, then we have the line of sights from each image. So if we intersect that, then we can make a 3D model. So we have got off-the-shelf products and also software technologies to run that. But what we are trying is how best can we use them for TxDOT.
We've been gaining information remotely with different types of scanners, with photographs and LiDAR. It's like radar but with lasers. The issue with the other methods of gaining data are that you have to acquire it on the ground. You either put it on a vehicle or you put it on a tripod. What happens is that limits your line of sight. So that limited line of sight only gets you part of the picture.
You could fly a drone both on top of the bridge and also underneath the bridge and collect the visual data, basically images of all the different parts. Like you can collect the beams, you can collect your wing walls, you can collect the abutments, and you can collect all the approach slabs and bridge deck. So you should be able to fly both on top of the bridge and underneath the bridge and collect all the infrastructure data. And then you should be able to see if there's any distress, like any cracking, any concrete spalling, or any wall movements.
If we take a cell phone and basically take a bunch of pictures around an object, we can stitch those images together and basically give you the volume of a stockpile. But the problem is that if something on top of that stockpile, if there's like a divot or basically a cavity in there, you really don't get a complete picture. But if I have a drone flying above, it not only gets the circumference, but it also gets the top part of that stockpile, and then it can stitch the whole image together and give you an accurate volume. So we're now doing volumetrics with this project that are within 1% to 2% of what the actual measured volume was. We are now able to do 3D modeling with the pictures. With those 3D modeling capabilities, we can now bring them into not only the CAD environment, but we can actually see how that works with our virtual designs. And we can even go as far, and we've already done this, we've printed out 3D scans of several projects with this research initiative. On the implementation side, we'd like to add LiDAR to it, and we'd like to see what, also we'd like to add infrared spectroscopy on it. What that will do is that it allows us to look into concrete structures. It allows us to see cavities or vacancies or voids or spalling inside of concrete that you cannot normally see through conventional methods. Once you have all this data, you know exactly what is wrong with your infrastructure. You know the condition, the health, the status of every part of your roadways, of your bridges. And knowing that, you know exactly where to target your funding. You're not just replacing infrastructure just to replace it because you're on a time schedule. You can actually wait and say, okay, I can triage this infrastructure versus this structure. There was a study done at the onset of this project, and they estimated for every dollar you put in, you would actually get $55 back. So, and that's the initial part, and that was only with photogrammetry. There was nothing else that we were attaching that return on investment to. So that could increase over time.
we're always interested in the business case because we don't want to use a technology just because it's new. The implementation project kind of follows on. We're going to take a real specific look at a couple of things that we think it could be very useful for us. And so that's one of the reasons we're going into the implementation project. Also, the implementation project allows our researchers to transfer all the knowledge that they gained during this 18-month research project back to TxDOT. And that is a huge part of the implementation. So there's going to be training. We're going to talk about the business case, when it makes sense to use it, when it doesn't. And hopefully from there, we'll have drones flying around and collecting data for us